5.4 is now that we know what logs are, and we can rewrite logs as exponentials and exponentials as logs. Logs are going to be more complicated than what we just saw in 5.3. So we're going to have to know all these properties. And it's crazy because you think these properties are just really random. Where do they come from? But remember, a log is an exponent. So think of all the rules that we had in exponent. When you multiplied bases, you did what to the exponents and so forth, okay? So kind of keep that in mind as we go. What's unfortunate about college algebra is we're going to learn all these techniques, and you're just going to wonder why. And you really don't get to see why until you go into your future math classes, whether that's trig or calculus or whatever it may be. So a lot of this we're going to do, and you're going to say, I did it, but you're never going to really see why and what the benefit of it is. So 5.4 is properties of logarithms. The first one objective is to convert logs of products, powers, and quotients in terms of an individual log. So kind of breaking up complicated things and making them a little bit more simple, and vice versa. If they kind of give you simple things, let's bring them together to make them complicated looking. So the first one's the product rule. So let's see what's going on here. It says, for any positive numbers m and n and any logarithm base a, if you are taking a log of two things that are being multiplied, you can separate them by addition. But again, think about where this is coming from. What do you do? Nope, you don't multiply, you do what to them? You add them. You add them, right? So notice that this is just a to the m plus n, okay? So that's just proof of our thing, right? We have log base a. Remember, log is another way to say exponents, right? So log base a of this multiplication thing, so how can we separate that? Well, multiplication is just the same thing as adding, okay? So what we're going to do, a couple of these, we're just going to just do it. And they don't say simplify or anything. They just say express it as the sum of logs. So the key thing you want to make sure, there's a couple things I want to point out, is you write log base a twice now, okay? So we're going to write it twice. The a stays the same, okay? And then one is of the first term, one is of the second term. So looking at this, we can write this as a sum because it's being multiplied. So how are we going to write this? This is going to be what?
Log 3
of what?
9.
And then what?
Log 3.
But plus, right? So it's going to write as a sum of log base 3 of 27. And the reason why this might help us, and in this problem we don't do anything, we're going to learn about little tricks. 9 and 3 are connected, 27 and 3 are connected, and so now that it's simplified like that, it might make it a little bit easier to solve, okay? Guys, we're just going to do the same thing, but we're going to work backwards, okay? So when it says express it as a sum, that means they gave it to us as a product, and we can write it as an addition problem. But then when they say express it as a single, it means they want us to take a sum and make it a product, right? So we're only going to, they're giving us this side, and they want us to write that side, all right? So we're going to write log once, log base what?
2.
2 of what?
P.
To the third times Q.
Oh.
You're just taking this, you know how we had a product and we made it 2 individual logs? They gave us 2 individual logs, so we just made it a product. So multiplication means addition. Think about that when you're multiplying bases, you add exponents, right? So logs are exponents, so that's where that rule comes from. Why might we go this way? Because sometimes we want the answer concise and condensed. But honestly, when it comes to math, it's easier when they're kind of separated, all right? So the next one is the power rule. And the power rule is derived directly from the rule just above. What's it mean to multiply something multiple times? 3, 3, 3, 3, it's 3 squared, right? And so it's just that repeated addition. So the power rule just says, for any positive number m, any logarithmic base a, and any real number p, if you're taking log base a of something raised to a power, the power can kind of just come down in front. Because the whole idea of m to the p, so say this was like m squared, that really is a product of m times m, correct? Let me show you this real quick. This is just an example. It's just a proof. You don't have to write it down. Say we had log base a of m squared, okay? Well, that can be rewritten as log base a of m times m. Do you agree with me? Yay, nay? Okay. What did we just learn up here about how we can rewrite a product? By add it. So this is the same thing as log base A of m plus log base A of m, correct? And how many log base A's of m's are you adding? 2 of them.
I can't barely see from the board.
Okay. So it's just basically saying that that exponent means repeated multiplication. But we just learned that multiplication can be pulled out as addition. And what's repeated addition? Just this product in front, okay? Think about that if that wasn't squared, say it was cubed. This would be written as log base A of m times m times m. So we'd have log base A of m 3 times, and so when you added it up 3 times, you would have 3, okay? So again, you don't need to know this. I'm just trying to prove to you that they're not these crazy rules that people are just making up. They're derived, okay? So just anytime you see the exponent, he can be brought down in front, all right? So let's look at this guy down here, example 3. We have log base A of 11 to the negative 3rd power. So how can we rewrite that? That's just the same thing as negative 3 log base A of 11. That power just comes down in front. B, some of us had some difficulty with this, but remember, this is why we had that whole section in O31 with radicals. How can we actually rewrite this radical as an exponent? It's 7 to what power?
The half.
Not the half, but the fourth, right? So whatever root you're taking, you're right there, Corey. Whatever root you're taking, that's the denominator, right? So just remember, anytime you have a radical, you can rewrite it as an exponent, but what can we do with the exponent? He can come down in front. So the answer to this would just be 1/4 log base A of 7. And then how are we going to write C?
E.
He is base E, but we're not doing anything with change of base, right? We're just taking care of the power.
So 6.
Yeah, 6 is just going to come down in front. So it's just going to be 6 natural log of x. And again, hopefully it makes sense that, because exponents can get kind of difficult. There's a lot to go on. So if you actually have to do math, it's easier to have them as like a coefficient in front than an exponent up there and complicating things. All right, so let's go ahead and look at our next rule, and hopefully this rule makes sense. Whenever you are taking a log of the same base of a quotient, m over n, it changes to subtraction. But again, where is it coming from? What would you do with this?
You would add the exponent. Right.
You subtract them, right? So remember in the front, multiplication and addition. Here, division means subtraction. Okay? So again, we're just going to pull them apart, because log is another way to write an exponent, right? So if we have a multiplication of exponents, that means we actually had an addition there. Okay, so let's go ahead and rewrite these. So it says express it as a difference, meaning they gave us a single log, and we want to pull it apart into 2 logs. So this will be log base t of what? 8 minus,
Log base T of W.
you got it. And again, you're like, well, why do we want to take this compact, nice thing and pull it apart? Because now we're just dealing with an individual log of one single number, A, or one single number, W. And it just makes some things easier when they're kind of by themselves singularly. You never get to see that, but if anyone's taken calculus or anyone knows somebody that's taken calculus, you start doing derivatives. And derivatives are a complicated process, okay? And it's easier when you have something like singular like that versus something that was kind of compact like that. All right, so now what are they going to do it? They want us to write it as a single log, meaning they're giving us a difference, and they want us to write it as one single log. So we're going to have what, guys?
Log base B, 64 over 60.
You got it. And then again, if they asked you to go further, we could, maybe reduce 64 over 16, but they're not. They just want us to write it as a single. All right, are there any questions?
Is that how it's going to be on my math log?
Yep, we're just going to go from one to the other. I don't know if they'll have us reduce. We can play around with that and see. So avoid these common mistakes here. Meaning when you see multiplication of a log, it doesn't mean multiplication of two logs, right? It means addition. There is no rule for addition, so kind of keep that in mind. There's no rule for this. So if you're taking a log of a sum, you're taking a log of a sum. There's no way to separate it, okay? This addition was actually, like these go together, right? That goes with that. When it comes to division, you don't take two individual logs divided. Remember, it changes to subtraction. And then if the whole log is raised to the p power, that doesn't mean the p comes down. That means that's log base a times n times log base a times n. That's different than log base a of n to the p, okay? So these are just kind of common errors to avoid, okay? Don't think these are the right things. So what we're going to do is we're going to take very complicated expressions that are all condensed into one single log and try to pull them apart, all right? So this is my best kind of order. It's not perfection, but let me we'll write it kind of small up here, my rules, okay? Rule number 1, look to see if you have a whole exponent. Meaning the entire thing that you're taking the log of is raised to an exponent, because that's going to be the first thing you take care of. The entire thing that you're taking a log of. So looking at A, each of them individually are raised to different exponents. There's not a whole exponent there, right? But looking at B, see how all of it's in the cube root? The whole thing's to the 1/3 power. That's what we're going to take care of first, okay? Number 2, the next thing you're going to take care of is division. What does division change into?
Subtraction.
You got it. So let's go ahead and write that down. So the next thing we're going to look for is division, and we're going to change that to subtraction. After division, look for multiplication, and what does he change to? You got it. And last but not least, number 4, look for single exponents. And we'll just call that it comes down to be a coefficient in front, right? So this is me making it up, right? Okay, this is my best way to kind of teach you to tell you what order to look at things. But it's kind of like a PEMDAS, right? Order of operations that we're going to follow. So everything's going to be different. It gets complicated. I can't show you every single example. So if you have questions, you go to your homework and you're kind of just struggling, bring those questions to class because we can look over them, because I can't show you enough examples really when it comes down to it. Okay, so A, does the entire thing that we're taking the log of have a whole exponent? No. So rule number 1, check, we're done with that, right? Rule number 2, or order of number 2, says look at division. Do we have division going on there? Yes. So what are we going to have? The x and the y will stay together in the front chunk because that's our numerator, right? And then the z will be on the back chunk because that's our denominator. So we'll rewrite this. Remember, the log stays the same. So this will be log base a of x squared y to the 5th minus log base a of z to the 4th. Is that okay? So you take the log of your numerator minus the log of your denominator, okay?
That makes sense.
That was number 2. Let's check it off. Number 3, do we have a log of a product in there?
Yeah, multiplication.
We do. You see the multiplications happening right here? So we have 2 things that we're taking the log of, x and y. So we're going to split this up to its own thing. Who's going to tag along? The minus log a of z to the, like, he's kind of just, hey, I'm hanging out as you split up that product, okay? So this is going to get a little bit extended. So this will be log base a of x squared plus log base a of y to the 5th minus log base a of z to the 4th. Do we have any more products to take care of? No. Well, I guess kind of, because that's what an exponent is, right? It's multiple products. So then rule number 4 is, do we have single exponents? Yeah, we have 3 of them. X, y, and z all have singular exponents, so they're all going to come down to be those coefficients in front, okay? So this will be 2 log base a of x plus 5 log base a of y minus 4 log base a of z. My log kind of looks like a 1, so make sure, okay. And again, you're like, why is that long thing any better than the beginning thing? It really is. When it comes to derivatives, derivatives are per variable, and all these variables are all up close and multiplied and divided. It's really complicated. But by extending them into these, the x is by itself, the y is by itself, the z is by itself. So anything we might need to do with it, it's a little bit easier, even though it's like technically longer.
I have a
It's, yes, ma'am.
Will we ever have to do like the single log with those long ones?
So we're going from,
That long?
yes, go backwards. Yep, that's going to be the next page.
Oh my God.
I know. So guess what we're going to do?
I feel like everything.
Order of
we've done, we
operations,
have to do it backwards.
Backwards, exactly. What'd you say?
Everything we've done, we also have to learn.
Yeah, you've learned it both ways, but that's a good question. So here in a second, when we turn over to the next page, we're going to be taking something like this and working backwards. So like instead of looking for single exponents, we're going to be looking for coefficients and making them exponents.
Oh my.
Right? You put your sock on and then your shoe on, but if you want to take it off, you have to take your shoe off first, and so you just work backwards. Don't get worried about it first. Let's make sure we feel good with this.
So we're going to use this type of stuff in calculus?
Calculus, for sure. And that's what sucks is a lot of times, a lot of you use college algebra as a terminating course and you don't go any further. So you learn all these tools, but you never really get to do this. There's actually a whole entire section in calculus called logarithmic differentiation.
Yeah, I'm going to go into calculus.
Okay, so when you take calc and you're doing logarithmic differentiation, think of me, okay? This is where we're going to use it, because they're going to want you to take a derivative of this, and it's really complicated because we have variables everywhere being multiplied and divided, where here it's going to be a lot easier, okay? So let's look at this guy. Let's first rewrite him, okay, as log base a of a squared b over c to the fifth, all raised to what power? 1/3. And notice I didn't put the log in parentheses, right? It's just what we're taking the log of that's raised to that 1/3 power. So Molly's order of operations, what's the first thing we need to look for? A whole exponent, which in this case we have. What we have to keep in mind though is 1/3 is going to be multiplied by everything we do from here on out. So we're going to have 1/3 kind of tagging along in front, and we're going to just have like parentheses or brackets behind it because it's like 1/3 times all this stuff, all right? So the first thing we're going to do is bring him down in front. I'm going to kill two birds with one stone because we don't have a whole lot of room. Is that okay if I bring the 1/3 down in front, okay? But then I go ahead and do step number 2. I change my division to subtraction. Is that okay if I do both at the same time? So the 1/3 will be down in front, and then we'll have log base a of a squared b minus log base a of c to the fifth. Okay? So I took care of that whole exponent and brought it down in front. But since all of it was raised to the 1/3, anything we do is going to be multiplied by the 1/3. What's our next move we have to do, guys?
The multiplication.
Multiplication, that's going to change to what?
Plus.
Plus, okay? So the 1/3 will hang out, and this will change to log base a of a squared plus log base a of b minus log base a of c to the fifth. And you guys will get good. Like you might, particularly you, Gavin, I feel like you can see a lot of things without writing it down. You might be able to do multiple steps at once. You know what I mean? Like when you guys are separating these, yeah. So like I'm someone that likes to see every single step. But when you're separating these and you know the next move is going to bring the exponent down, you might be separating them and bringing the exponent down at the same time. That's fine, okay? So the next thing we're going to have is 1/3. The 2 will come down, so we'll have 2 log base a of a plus, the b doesn't have an exponent, so he'll just stay log base a of b. And then what's the last one going to be? Minus 5 log base a of c. Okay? For purposes of my worksheet, for my test, I would be okay with this, okay? My math lab, I don't know if I can squeeze it in there, but my math lab might want you to do, sorry, is that thing's in your way, isn't it? My math lab might say, well, this still is kind of complicated because you're still having everything connected to this 1/3. So what's the one last step they might have you do? Bloop, bloop, bloop. Yep, distribute it, okay? And this is just when I use a calculator, but 2 times 1/3 is just 2/3, okay? So the final answer that they might want, and I don't know, I would take either or, so I'll like circle both, is going to be 2/3 log base A of A, okay? Because that's just 1/3 times 2. The log A of B didn't have a coefficient, so that 1/3 is just the coefficient. Log base A of B minus 5/3 log base A of C. Ooh, I know it's really small. I'm sorry. I know, Riley, you're probably going to have a hard time getting it on yours. And again, the whole idea there is that it's still complicated because you don't really have things individually when you have that 1/3 out in front of all of it. So if you can distribute the 1/3 to each part, then you can individually look at just the A,
That was gonna be my
just the B,
question.
just the C.
I was gonna say, how do you get rid of it, because I thought it would still be considered a whole exponent,
Right.
so.
And
yeah.
it's kind of what it is. Like you haven't individually spread it out yet. So this is probably going to be the step my math lab's going to want you to go to. Again, Braden might be the only one that gets to experience why, but it's nice to just look at each individually versus this cluster that's happening here. Okay? So
Well, that was a rough one.
turn it over to the top. We have one more, okay? And then we have the backwards one that you were talking about. Okay, so why I threw this one in, it's not a whole lot different than the one we just got done doing. The only differences that we have to be careful of is that when we separate, like what's the division change to? Subtraction. Realize that we have like this product behind it. So we're subtracting all of it. So I'll show you what I'm talking about, okay? So what's the first thing we're going to do? Do we have a whole exponent? No. So we're just going to do division into subtraction first. So this will be log base B of AY to the 5th minus log base B of M to the 3rd N to the 4th. Is that okay? But then the next rule is multiplication switches to addition, but what we have to keep in mind is that this negative is in front of all of this, okay? So when I split this into addition, I'm going to actually put parentheses around it, or if you kind of know what's going to happen, you're going to be distributing the negative. I like to show the steps though. I don't like to go right to it, so I'll show you what I'm talking about. So both of these have addition, so we're going to separate the A and the Y to the 5th and the M 3rd and the N to the 4th as addition each. So this will be log base B of A plus log base B of Y to the 5th minus this entire, so put a parentheses because it's this addition. Log base B of M to the 3rd plus log base B of N to the 4th. Because we're saying I want to subtract all of this log, all of this product, right? But all of that product is really a sum. So what do you think we're going to do with that negative? Distribute it, okay? Nope. Negative times a positive will actually make it
Oh, I wrote a
negative there, okay? So is that okay just to kind of say room that my next line, I'm going to be bringing the power down. Are you questioning the distributing?
Yeah.
If you had this, I'm just making up these numbers, okay? X plus Y minus 3 plus Z. And I say get rid of the parentheses. What do you have to do to get rid of the parentheses? Distribute the negative. So he's going to go to the 3. So the 3 will stay negative, right? But he's going to go to the Z, and the Z will become...
I can't see your recording. There's no
Oh, no. Is that okay?
Yeah.
Which is funny because they don't even see that. They're like, what is she talking about? Okay? So the X plus Y will hang out. The negative will make the front number negative, but that's kind of what you would do anyway, right? But then the negative will also make the back number negative, okay? So we want to subtract all of this log, and this whole log was a product, which was really addition, but we need to subtract all of this. And right now, if you don't have the parentheses here, if you don't distribute the negative, you're only just subtracting the M part, okay? So we're just going to distribute him here and there. Is that okay?
It just makes everything.
It makes everything negative, yep. And so as I do that though, just to save us like writing and lines, I'm also going to bring my powers down in front, okay, to be my coefficients. So A didn't have a power, so he'll just stay log base B of A. Then he'll be 5 log base B of Y. And then he'll be minus 3 log base B of M, is that okay? And then minus 4 log base B of N. And we have it.
It makes sense, but I feel like it's gonna be hard when I do the worksheet.
And that's what I'm here for. That's the whole point of the worksheets too, guys, is to make sure you can kind of do it on your own, but I'm still in the room to correct you. You know, it's not like, oh, go fly by yourself. You know, I'm here to
I know,
to
Mama's like,
kind of
"Oh."
guide you. All right, so this one is kind of tricky. What I would do, you don't always have to change the order, but I think this is kind of tricky. Addition is commutative. What does that mean? It means 2 plus 3 is 3 plus 2. It doesn't matter where addition happens, okay? Subtraction is not commutative. So like this, if I wanted to move him to the front, he would still be a negative up in front, okay? The only reason why I'm pointing that out is because this is a plus sign, and you think it's kind of like what we came off of, negative of a product, but it's not. Because if this was a product and there was a negative in front, he actually would have been a minus sign there, okay? So I'm actually going to rewrite him. And this is rare, so it's not like you have to do this every time. I'm going to write him up here in front. So I'm going to rewrite this as 1/4 log base b of z plus 5 log base b of x minus log base b of y. Now, if that was a minus minus, technically you would distribute a minus out. I think you might have one like on the worksheet that I can help you out with. Okay. So this is what Corey was anticipating. She's like, okay, so we took these single logs and we stretched them out to these multiple logs. Are we going to have to go backwards? Yes. So I will rewrite. It really is just what we wrote, but backwards. So if you can remember, what was the last thing we took care of at the very end? The powers were the coefficients, right?
So you put it back.
So you put it back. So you're going to look for coefficients first.
Log base b z to 4.
The 1/4, right? Which in a second we're going to change to a radical, but not yet, okay? And this will be log base b of x to the 5th minus
Oh my gosh.
log base b of y. All right, so that was step number 4. Now if you flip it back over, remember step number 3 was look for multiplication and change it to addition. So what are we going to look for? Addition and change it to multiplication. So do we see addition there? We do, okay? Do you guys see the addition right here? So as I do this step, I'm going to rewrite my exponent of 1/4 as the 4th root, okay? So, and I'm going to kind of change the order because since he's a root, I kind of want him in back, okay? So I'm going to write this as log base b of x to the 5th, the 4th root of z, okay? So I took the addition and made it a product. I just put the x5th in front because that's typically what we do. If you want to write the 4th root of z and x to the 5th behind it, that's not wrong. You just have to make sure it doesn't look like the x to the 5th is in the 4th root. Does that make sense? You know, because if you put them behind it, that's fine, but I'm like, is he part of the 4th root? I don't know. So we typically just leave our roots in the back, but it doesn't really matter. It's either or. Okay, and then minus log base b of y is just hanging out. And then what was the next step if we're working backward? You look for division and made it subtraction. So now we're going to do subtraction and make it division. So this is going to be,
This is kind of difficult.
This is not exciting.
it is not, I love this stuff. No one's with me?
Maybe once I get
Okay, I don't know why I like it. Just putting things in their place. X to the 5th and then the 4th root of z will all be over y. If you want to put parentheses around it, you can.
Order of that messed me up. Like I had the Z on the bottom originally.
Right, but the z doesn't have a minus in front of him, so he shouldn't be in the bottom, right? And that's what, again, now if this was minus minus, so yeah, that one's a little bit different. I would not have one like that on the test. Like maybe minus minus where you would factor out the minus so he'd look like this, so you knew all of that was in the bottom kind of thing. But you can't do that. All right, that's a good stopping point.